Hello and good day everyone. I'm Engineer Jack Bertolvo, faculty member of College of Engineering and Geosciences under the Department of Agricultural and Biosystem Engineering. Okay, so starting this video, I will be the one who will discuss the remaining topic of and I under the AS13, which is Engineering Data Analysis, starting from multiple linear regression up to a multifactorial design of experiment. Okay, so for today's lecture, I will discuss multiple linear regression. Okay, so I hope that everyone's ready and let's start. Okay, so before we proceed, let me post this statement first that the simple linear regression and correlation analysis has one major limitation. So try to post for 10 seconds and try to think what is this limitation. So I think uh, most of you or all of you already know what is this limitation. Okay, so I hope that you already has the answer in your mind. So the answer is that it is only applicable to cases with one independent variable. So it's simple as that. So simple regression is only applicable if you're using one independent variable. But in many instances, a better prediction can be found for a dependent or the response variable by using more than one independent variable. Okay? So because this is the reality, if you're doing an experiment, you cannot only use if you're trying to predict something. Let's say you want to predict your final grades in AS13. Okay, so you're trying to create a model. So what would be my final grades? So you set factors that could describe or predict the variability of your grades. Let's say the time you spend in studying. Okay, so if you're using just one independent variable, just like the time you spend in studying, the question is this enough? Is this enough that could explain the variability of your grades? So you need to solve for this. So you need to create an equation for simple linear regression, then try and observe the r squared if it is high or low. But let's say that you come up with a very low r squared. So just recall in your simple linear regression the r squared or the coefficient of determination. So if you're having a low coefficient of determination, you can say that ah uh, my independent variable is not enough to describe the variability. So we need to include another set of independent variable. Let's say the time you spend in playing mobile games. Maybe you're just addict with playing Mobile Legend or Dota, something like that, and other extracurricular activities. So if with that set of independent variable, if you conduct regression analysis, you cannot use simple linear regression because you're using different you're using many independent variables. So there's a need a regression procedure that can simultaneously handle several independent variables. So this is that's why nga multi-limitations sa simple linear regression. Okay? So regression analysis involving more than one independent variables is called multiple regression analysis. Okay? Multiple regression analysis is a general term because there are a lot of multiple regression analysis nga model. Okay? But when all independent variables are assumed to affect the independent variable in a linear fashion and independently of one another, the procedure is called multiple linear regression analysis. So, mo na siya atong focus. Focus lang ta sa multiple linear regression analysis because there are a lot of multiple regression and multiple regression model. We have the quadratic, the two-factor interaction, the power, the logarithmic. But this time, we will only focus on multiple linear regression. Okay? So, the simple linear regression. Oh, balik. Okay, so what is the form? So, this is the basic form of multiple regression equation. You have y, which is the independent variable, a dependent variable. Then the alpha, which is the y-intercept. Then you have x1, x2, and x3, which is the independent variable. And you have beta 1, beta 2, and beta 3, and beta k, which is the coefficient of your every independent variable. Okay? Then, so how to interpret, because the important part here is how to interpret this beta. Okay, so how to interpret these betas. So geometrically speaking, this equation here is describe a plane. If we have a software, I can show you plane gid siya ang pagka-describe nino. So how to interpret? So for a fixed value of x1, let's say that we hold x1, this independent variable here, we hold this as constant. Then we let x2 varies. Then we can say that for a fixed value of x1, the mean of y changes by beta 2 for each 1 unit increase in x2. Okay, so it's pretty simple, no? If we hold this constant, because this this beta here is alpha. Sorry po. If we hold this, if we let this independent variable constant and we only allow the second independent variable change, then we can say that if this x2 change by 1 unit, let's say the value of x2 is 1, then we can say that there will be an increase of y by beta 2, because 1 multiplied by the value of beta 2 is beta 2. So this is the increase now of y. So if we hold this x1 constant, then y changes by beta 2 for each 1 unit increase in x2. If y is expressed in logs, then y changes by beta 2% for each 1 unit increase in x2, and etc. Just for this equation lang na yung duha ka independent variable. Okay. Next. Let's proceed now to one. So that's the short introduction of what is a multiple linear regression. So let's proceed now to the procedural analysis, how to come up with an equation or a model for a multiple linear regression. So the data required for the application of the multiple linear regression analysis involving k, which is k is the number of independent variables, are n multiplied by the quantity of k plus 1 observation. So n is the number of observation and the number of 1, then k plus 1. So this is the total data that you need to acquire in solving. Okay, so I made a procedural analysis here. So but before anything else, so this is the highlight of this equation here, the n multiplied by k plus 1. So this is the total observation that you need to have in order to solve for the regression model. So you have, if you have 2 observation, then you have two independent variables, x1 and x2. Then you have 1, 2, 3, 4, 5, 6, and 7. So all those data nga kinahanglan nimo. So magdepende lang siya. Now, let's try an example in order to discuss properly the procedural analysis of regression model, multiple linear regression. So let's say, for example, we have this find the effect of plant height and the number of tillers to the yield of rice over 8 varieties. Okay, so inani ang experiment. So we try to find the effect kung natay different varieties, 8 ka varieties sa atong rice daw, sa atong tanom karon. Unsay effect kung ang plant height niya og na number of tillers kanang pila ka buok ang naibunga. So mo siya atong observe unsay effect niya karon sa yield. Kung taas ba ang atong hypothesis dira, unsa kay atong mga assumption, kung taas ba ang plant, daghan ba siya og maani or daghan ba siya bunga, kung daghay tiller daghan ba siya kuan bunga pud ana, or unsa ba. So mo na siya atong mga assumption before we start. So we create a model, standard model, that y is just equal to alpha plus beta 1 x1, which is x1 is the independent variable 1 and x2 is the independent variable 2. Then we have the coefficient beta 1 and beta 2. So, ang objective na to is to find the coefficient beta 1 and beta 2 and also the alpha in order to predict y. Okay? We need to find this beta 1 and beta 2. Okay, so we have this table here. So we have the yield. This is for variety 1, 2, 3, and 8. So for variety 1 daw, na siya yield nga 5,755. Ang plant height niya is 110.5. Then the number of tiller is 14.5. Okay? And so on, padulong sa 8. So from this data here, class, we need to come up with a model. So we need to solve for beta 1 and beta 2. Also the y-intercept. Okay. So the next thing to do, so inani ang first step there. So we need to compute the mean. Okay? Mean. We need to compute the mean and the corrected sum of square for each variables. For y, x1, x2, and so on. And the corrected sum of square of cross product for all possible pair combination of x1 plus xk plus 1 variables. Okay? Okay, so this is now the summary table of the value that you need to calculate in order to solve or in order to formulate the regression model. Okay, so from this table here, again, you need to calculate the mean. So, pila atong variable na atay variable nga duha. So, x1 and x2. So, x1 and x2. So, pila unsa mga data atong kailangan i-calculate. So, we need to calculate the mean. So, we need to calculate the mean for x1. Then, we need to calculate the mean for x2. Next, the corrected sum of square for x1, which is kani, x1, then corrected sum of square for x2. Okay? Then, we need to calculate the corrected sum of square of the cross product of x1 and x2, which is kani. Then, the corrected sum of square, a cross product of x1 and xy, then x2 and xy. Then, including the corrected sum of square of y. So, pila to kabuk ng data? 1, 2, 3, 4, 5, 6. So, there are 6 equation nga atong kinahanglan nga i-solve para maka-formulate ta karon. Kay since we're only having duha lang ka independent variables. But for instance class nga kibali tulo. Sir, what if tulo, sir? So kung tulo, so natay x3. Natay x3 so need na to i-calculate ang mean sa x3. Then we need to calculate the corrected sum of square dari nga part. Kaya kung imo siyang i-observe, naka-diagonal na siya class. Kung x1 dari, x2, ang sunod dari x3. Kung then cross product niya, kung x2 dari dari x3. So nakay x2 dari, x2, x3, x3 dari. So I will show you sa last part kung giyon sa na siya. Then including na po sa corrected sum of square of the cross product of x3 and xy. But this time we only have two independent variables, so let's stick with katong 6 nga for equation nga kinahanglan nato i-solve. So okay, so these are the so I think the same lang siya with the simple linear regression equation. So for x1, the corrected sum of square for the first independent variable is we have this formula here. This xi here is for x1 na siya, close na ko siya for to note that this is for x1. So I start to once just summation lang. Then I think the better way to solve this one is to have a table that shows the every x, katong x, then minus siya sa mean. Then katong result niya is squared lang nimo. Is squared tapos just add the better one. Then for y, the same formula. I think you're already familiar with this because it's already not already. It's almost the same. I think it's the same good siya sa kuan. The problem is nga natay mga additional nga na dungag na siya additional nga ma-formula. Okay? So for the corrected sum square for the cross product, we have this formula here. Just remember, if x1, x1 you dapat the y, y. Okay, so this is for x1. Remember the notation, the summation. Then I equals to 1 up to the n. Just familiar, you're familiar with that, I know. Then the same, there are 6 again. Katong akong gi-mention ganyan, there are 6 kuan nga tong kuhaon, no? So x2 and xy, then x1 and x2. So using that equation, then using this table here, we need to solve for those 6 values. Okay, so I already gisolve na ako siya daan because it's it will consume time if diri pa nako siya i-solve. And using the formula here, but you can katong as I mentioned, you can solve it again using sa katong mag-create kag table or something or if your calculator can carry sa katong tanan nga value. There are only 8 but I think kung sa calculator magdili na niya kaya. So I just solved the 6 kinahanglan siya. So for corrected sum square for x1 atani sa y, then sa x2, then the corrected sum square for the cross products x2 and xy, x1 x2, and then x1 xy. So we have this data. So using this data class, we need to solve for beta. Again, though, about ang objective, we need to calculate the coefficient for every independent variable in order to predict y. So using this, kabalo naman tanga mo ni siya ang formation sa atong duha ka. So ang atong step 2 is to calculate the beta using sa katingkuan. So from here, kani diri iya siyang gi-emphasize nga beta 1 is x1 mo na siyang notation. Coefficient niya is kani, then beta 2, so on and so on. So, kung pila ka buka independent variable. So kani gikuha lang ni siya sa beta 1 is diri. For beta 1, x1, then beta 1, beta 2, beta and so on. The same with kani beta 1, beta naka vertical gina siya. Beta 1 diri tanan, beta 2, beta 3. Then kaning notation diri, node not notation. Kaning mga value nga ikuan is gikuha lang na siya sa diri. x1 ka. So, sir, blanco man na dira sir nganong naman na di siya. Gi-blancohan na siya but ang value ana niya is the cross product of x1 and x2, which is kani x1 and x2, which is the value of this the same na siya diha. Okay, so after that ato siyang i-simplify. Atong k is only 2, so therefore the number of independent variable nato is 2. So we already nalang tayo duha pud ka equation. So beta 1, x1 is 2, and x2. So we have this equation now. There are 2 equations. So there are different techniques in order to solve for beta, since we have the value for this, and this. So nata na value. So ang unknown na lang is beta 1 and beta 2. You have 2 equations, so you can solve 2 equations, 2 unknowns. You can use directly in your calculator, or you can use an elimination method. Okay, but for me, I equate this equation here. This first equation I equate in terms of beta 1. Then after that, beta 1 is substitute siya sa equation 2 para ma-express lang nimo ang equation into beta 1 lang tanan. Okay, so mo na siya ang nahitabo. So pag express na ako karon, ningani ng equation. But you can solve kung unsa inyong mas ganano at it's sa algebra nga topic siya. So kung unsa pinaka easiest way tingali nyo in order to solve for beta 1 and beta 2 is lang mo lang i-follow. But for me, ako lang siyang para ma-emphasize siya nga so akong gigamit is gi-equate lang nako ang both equation para ma-express siya ani. Then all the values are available na from our previous calculation. Then solve for substitute lang. Then you can calculate that beta 1 is negative 23.75. So this is now the equation, this is now the coefficient for the first independent variable. Now, we need to solve for the coefficient for the second independent variable. So we need to solve for beta 2. So I express again, or you can substitute directly the value of negative 23 in order to solve for beta 2. Gusto ko magpahago-hago, joke. So inano siya, I express the equation lang pod into beta 2. Then I solve that beta 2 is 150.27. Okay, so I have now the two coefficient for independent variable. This is for x1, negative 23.75, then 150.27 for x2. Then after that, for step 3, I need to solve for the alpha, which is the y-intercept. So, using this equation, katong na formulate now, we will use the value of the mean. The mean of the y is just equal to alpha minus, which is the coefficient for x1, 23.75, x1. This is the mean of x1, then 150.27 multiplied by the mean of the x2. Remember ha, mean na itong gigamit na rin nga part ha, not the observation nga value. So mean, just substitute this value. You already calculated this value here. Then you can calculate that the alpha is 6,336.24. So that's the value for alpha. Now, our equation is finished. Therefore, the estimated multiple linear regression equation relating plant height, which is x1, and the number of tiller, x2, to yield is y is just equal to 6,336.24 minus 23.75 x1 plus 150.27 x2. This is now the equation in order to calculate the average of the average yield relating to the plant height and the number of tiller. Okay? Now, the question is, how good is this equation? Is this good enough to explain? Is this really true? Nga ma-explain siya kung kaniya itong gamiton. Now, we need to test, or again, sa inyong simple linear regression, we need to calculate the R squared. Okay? So, before we calculate the R squared, we need to compute first the sum of square due to regression, or the SSR, the residual sum of square, the SSE, before we calculate the coefficient of determination, or the R squared. Okay, so we already have the formula for this. The kalahian niya is we're using two independent variables. So, for this general formula, which is PI, represent that the number of independent variable, XI also dependent. So, by expanding this formula that we're using 2, we have this formula for SSR for two independent variables. All the values are already solved. Just plug in. Then you can calculate that SSR is 2,631,804. Okay? So, after that, compute the residual sum of square. The corrected sum of square for y is already computed, minus the SSR. Then SSE is 579,700. Then, after that, you can now calculate the R squared. Okay? Then R squared is just SSR over the corrected sum of square of y. Okay? Then you can calculate, your calculation will result to 0.82, or if we express that into percentage, it's 82%. Okay? So it's 82%. So what is this 82% means? It means that 82% of the total variation in the yields of 8 varieties can be accounted for the linear function involving plant height and tiller number as expressed in step 3. So it means, class, that dependent variable is the variability of the yield can be explained by using plant height and tiller number. 82%. So 82% kibali out of 100% sa variability sa atong yield, 82% of that can be explained if we will use the plant height and the Taylor number. Okay? Okay? Mo na siya, no? Mo na siya ang pasabot sa R squared. So, 82% of the variability of the yield can be explained by using the plant height and Taylor. Okay? Now, karon we have additional nga analysis to test if this 82% is significantly different from 0. Okay? Now, we need to test the significance of R squared. We will use the F value. So, we have here the formula for the F to calculate the computed F. And we will compare this to the tabulated F. So, we have this formula here. This formula, all the values as R, we already calculated that. SSE, we already calculated N. We all have the value of NK. They just substitute, then calculate the F. Then we calculated that F is just equal to 11.35. Now, we need to test for the certain level of significance at 5% and 1%. Okay, so we need a degrees of freedom for K, F1, which is F1 is just equal to K, and F2 daw is just equal to N minus K minus 1. So for this, then we need to compare the F value, the computed F value to the tabulated F value. Okay, so I will show you just one. So our F1 is 2, which is K, and our F2 is 5 here. So we have a value for, this is 13.27 is for 1%, and 5.79 is for 5%. Okay, now for the tabular F values, siya no, 5.75. Okay, since ang atong calculated is 11.35, therefore we can say that it is significantly different from 0 at 5% level of significance, because 13.27 is higher compared sa katong 11.35. So significant siya at 5% level of significance. So may kaingas naman daw. But smaller than the... Okay, so now nag-express na. Thus, the combined linear effect of plant height and Taylor number contributes significantly to the variation in the yield. Okay, kabalo man ta karon na-solve na nato, no? We know that our equation, our R squared is significantly different from 0. Ito nga, ang R squared na ako, 82%. So, therefore, 82% sa the variability sa akong yield can be explained by the plant height and the number of Taylor. Okay? Tapos, I test the significance. It is significantly different from 0. Okay, so my model is good. Okay? Although, but, bisan pag nani atong points nga, remember that. Although the significance of the linear regression implies that some portion of the variability in y is indeed explained by the linear function of the independent variables, the size of the R-squared value provides information on the size of that portion. Obviously, the larger R-squared value is the more important the regression equation is in characterizing y. On the other hand, if the value of R-squared is low, even the f-test is significant, the estimated regression equation may not be meaningful. So, inana siya. Let's say that you have, will let you choose. There are two models. First is, a model is, ang R-squared niya is 90, but not significant siya. Another model is, R-squared niya is 30%, then significant siya. Now, which model is good in predicting y? So, the answer is, katong higher ang R-squared, because this is the main point of regression. You need to set the independent variable that could predict the variability of your dependent variable. So this is the really important, because R squared is, some of the research studies, they set a standard for a value of for social studies, 50% or below, they're accepting it because it's really hard to conduct an experiment for society. That's why if they are come up with 50% or 60% or R squared, they're accepting it. But for engineering, having an R squared below 60 or 50, it's not good because kung ano, sumugin na siya sa engineering apart. So that's why sa most of the engineering studies, ang R squared good, it's 80, 90, most uban pa nay halos mag 98%. In order to describe that the variability of the dependent variable, the response can be explained by the set of independent variables. Because in engineering studies kaya man i-control. For societies dili lisod siya. So mo na siya importante nga i-kuan nga the higher the R score the better, even though nga dili siya ingon nga significant, because if dili siya significant we can say dili siya maka-affect linearly. Maybe there will be another form of regression model, maybe quadratic, maybe a power para ma-explain siya in kuan, because ang linear lang man, ang linear effect atong gi-consider that. Okay, so now kabalo ta karon nga significant siya naagikan. So 82%. Let's say 82% karon sa akong kuan, sa akong model is sa independent variable kan maka-explain siya sa variability sa atong dependent variable. Now the question is, among those independent variables, asa gyud ang maka-affect significantly? We're using two independent variable. The question is, kani ba yung duha ang maka-affect sa yield significantly? Basin nga 82% lagi siya, significant siya. But ang plant height ba maka-affect ba siya, or ang tiller lang, or ang duha gyud naka-affect significantly? So we need to test the coefficient of our independent variable using a t-test. Okay? So using a t-test, familiar mo t-test, you already done with t-test man. So we need to test the individual coefficient if ang coefficient ba gid niya naka-affect significantly or not. Okay? So isa-isahon nato siya. So use a t-test to determine the significance of each coefficient. Then calculate the standard error for every independent variable. So we have this formula class for SSE, then for S, then for S beta I. Okay, so I have here, I try to this for that one t value in order to calculate the t value. Okay, so I try in my solution here, I try to calculate I test the coefficient for beta 1 lang. So I test for beta 1 because it's plant height. My concern is this plant height affect significantly or not? Because kung imo siyang hunahunahon, maka-affect pa ka kung taas mo tanom or dili ba, maka-affect ba gid siya. Okay, so I try to calculate kuan. So using the formula nga gi-present, all the values are already solved. Na nato tanan, available na to tanan. No? So just plug and play lang. Then calculate, then just follow the formula lang akong gi-present. Tapos just like that. Then I calculated that the computed t value is negative 1.89. So just neglect the sign. It's 1.89. Then compare that into tabulated sa t distribution table. Ang value for 95% is 2.447, then 3.705. Therefore, it's below sa tabulated. Therefore, naka-affect, my model is 82% of my model can explain 82% of the model can be 82% of the variability of the independent variable can be explained by the set in the independent variables. Then I test the significance. It's significant. It affects significantly. Linear na siya, linear effect. But the question is, among those two independent variables, asa did you good ang maka-affect? But so I come up with a t-test. So I gitest na ko siya ang plant height, kung ang plant height maka-affect ba yun. But the result shows that no sufficient evidence that plant height affects significantly sa yield. Therefore, so we need to test again. So wala na ako siya gi-solve na. But for you, try to solve for beta 2. Try to i-test ang beta 2 if it is significantly different or it is significantly affecting the yield of because since for sure it's significantly affecting because naman gi significant effect katong base atong r squared nato natay linear effect, then we come up with beta 1 nga wala siya significant effect. Therefore, it will follows that beta 2 is mo naka-affect gyud sa yield sa atong plant. But as a practice, you try to solve, just follow the solution. Just change, from beta from x1, you try change to x2. So all the data are available, then just solve for it. Okay? So another example. So referring to the previous example, let's say that we add another independent variable, which is x3, which is the amount of the fertilizer. So derive a regression linear model, test the significance of the developed model. So kanina hitabo, from our calculation, we come up 82%. Then 82% ng r squared is not enough. Maybe na you think that napatingali gyud pwede nga independent variable nga maka-explain pa gyud nganong inani atong yield sa kaning variety. So maybe you think that siguro ang fertilizer nga gian, so atong include karon ang amounts of fertilizer. Okay. So we have this table, set of data. So nanatay na dungag nga value, which is the amount of fertilizer. Okay. Karon from here, kato kaning table, from two independent variable, abot na taog tulo. Okay? So this is the summary of the create a summary. Okay. Ang value nga itong i-solve is naka-triangle na siya. Kani sum of square, corrected sum of square for x1, x2, and x3, then y. Then including na po din ang after kaninga diagonal, pasaka din tanan. This is the corrected sum of square of the cross product x1, x2, x1, x3, x2, x3. Then the corrected sum square of the cross product for x1, x2, and xy to y. Okay, sir, kaniding na rin, sir. Anong di mo na i-appeal? Okay, x2 and x1 is the same with this. x3 and x1 is the same with this. x3 and what is the same with this. So therefore, do not include this. You will include this in your solving for beta. But for the solution lang, to calculate these values, kanilang naka-triangle. Naka-triangle lang siya, class. Okay? So that's the values that you need to solve. After that, after ma-solve din mo, let's say na, nakalculate na ako ni sir, tanandre. Nakalculate na. Then proceed sa pag-calculate karon sa beta. Okay, so pag-calculate sa beta, use this. You can use this equation lang gyapon. Tari tanan, beta ni tanan. Beta 1, beta 2, beta 3. Okay? Then equate siya equal to kana sa y. Y man niya, y equals to anana. So butang na mo dira y beta 1, beta 2, beta 1, beta 1, beta 1. So mo na siya nahitabo sa diri. So x1, x2. So ito i-compare x1, x2. X1 squared, x2, x1, x2, x1. So the same na siya da. So after that, nanataan kibali nanatag value, nanakay value ani tanan. Then you solve for every coefficient, beta 1, beta 2, and beta 3. So unsa nga way nga mas dali sa inyo para solve? Sa ako, kung calculator lang gamiton, I will use sa kanang mode sa kanyang calculator, kanang sa equation 5 then 2. Just inan lang equation, click ang equation 5. Ang equation is 5 then 2. Then just plug in the data kana. So equation solving 3 equation with 3 unknowns. So just makakuha na ninyo ang beta 1, beta 2. Okay, so we will not solve that. I will leave this as assignment for you. So using all the data from previous example, derive the linear regression equation. Calculate also the coefficient of the determination and determine the if it is significant at 5% and 1% level of confidence. Conduct a t-test for the individual regression coefficient and determine which independent variable has a significant effect to the variable. Okay, so I will leave that assignment. After this lecture video, the next page will be a link or a test for you. Dito niyo i-attach ang inyong result for this assignment. So you better watch this video para kan. Okay, so I think that's all. And we will next meeting we will discuss introduction of the design of experiment for single factorial design. Okay, so that's it, and thank you and goodbye.